Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe to my YouTube channel. Also click on the notification bell so that you can get prompt notification anytime I publish a new content. In today's video, I want to run another potentiometer experiment. I would like you to click in the description box below. I did a potentiometer experiment using the ammeter and the voltmeter. But in today's experiment, I want to just concentrate with a potentiometer experiment with just the ammeter. If you click in the description box below, you will find videos on the theory of potentiometer, Wheatstone bridge, meter bridge, also calculations in current electricity. So let's begin. A quick recap for what I did in the other video. I said in the other video that a potentiometer is simply a device that precisely measures the EMF in a cell or in a circuit with no mistakes. A potentiometer is also a device that is used in finding the value of the unknown resistance in the circuit. In every experiment, there are equations that controls the experiment. These equations will help you as a student or a teacher to know if what you are doing is right or wrong. So, for this particular experiment, before I write down the equations, I have written these equations in other videos, but for the sake of emphasis, I will still rewrite this equation right now. But before I do that, recall that there are factors that affect the resistance of a wire. Namely, one, the length of the wire. The length of the wire, when it decreases, the resistance of the wire will increase. The cross-sectional area of the wire. Increase, decrease, decrease, increase. When the cross-sectional area of the wire increases, the resistance will decrease, and vice versa. We also have the temperature. Increase in temperature will cause the resistance of the wire to increase. And then the other one is the nature of the wire or the resistivity of the wire. All these are summarized in the equation I write. That the resistance of the wire R is directly proportional to the length of the wire and inversely proportional to the area of the wire. Removing the sign of proportionality, we write that our R is equal to rho L all over A. You can call this your equation number 1. This is the equation we are going to use to determine the value of the unknown resistance in the circuit. In this we have R here. So if this resistance is labeled R, in the experiment at the end we're going to evaluate some stuff to get the value of the R. Now, I want to go deep down to give us the real equation that is controlling today's experiment. For equation number 1, recall that from Ohm's law that V is equal to IR. You can call this equation star. Equation star star. So if we make R the subject formula here, we say that our R is equal to V all over I. Now it implies that substituting the value of R in equation 1, we have it that our V all over I is equal to rho L all over A. We call this equation number 2. It will interest you to know that this equation number 2 is the equation controlling the whole of this experiment. It means that as we are running the experiment, increasing the length of the thread will increase the voltage. However, in today's experiment, we are dealing with just the ammeter. So it means that the increase in the length of the thread, of the wire, will cause the current to decrease. Increase, decrease, decrease, increase. So we are going to have an increase-decrease trend. For an increase-decrease trend, I told you that you're going to have a graph of this nature. Lovely. Now, another equation that is very, very important here is E1 all over E2 is equals to L1 all over what? L2. These are the possible equations that are going to be used in this potentiometer experiments. We can call this equation number 3. Equation number 3 is a potentiometer equation that is used to determine the value of the unknown EMF in the circuit or in a cell. So these are the basic potentiometer equations. To this, we will proceed to run the experiments. Let us look at the instructions for the experiments quickly. So, this is 2009 Waec. So we don't have time. You can quickly look at that. If you have watched the other video series that I have done, we are going to use the same pattern to generate our table of values. Connect the circuit as shown in the diagram above. This is the circuit diagram. Above, PQ is a potentiometer wire 100 cm long and R is the standard resistor of 5 ohm. With the jockey J not making contact with PQ, close the switch. Read and record the ammeter reading I. Open the switch. Use the jockey to make contact with PQ at 20 cm mark such that PJ is equal to L equals to 20 cm. Close the switch. Read and record the value of I of the ammeter. Evaluate L inverse. Repeat the procedure for other values of L equals to 35, 50, 65, and 80 cm. In each case, determine the corresponding value of I and L inverse. Tabulate your readings. Plot a graph of L inverse on the vertical axis and I on the horizontal axis, starting both axes from the origin, 0, 0. From your graph, deduce the value of I naught of I when L inverse is equal to 0. Evaluate L naught over I. State 2 precautions taken to ensure accurate results. Define the EMF of a battery. A cell of X of EMF 1.00 volts is balanced by a length of 40.0 cm on a potentiometer wire. Another cell Y is balanced by a length of 60.0 cm on the same wire. Calculate the EMF of Y. Lovely. So, we are going to generate our table of values. If you watch the other video series, we are going to use the same pattern to generate our table of values. So, we'll start with serial number. We start with serial number. So we'll say that this is serial number. Good. The length of the thread is a parameter in this. The length of the thread, you can screenshot or forward the video back to see where I brought this close to the camera. So the first PJ is L, and that's L is in cm. So we draw a straight line here. I told you your table of values carries the highest marks in your physics experiments. That is why in every video I run, I take time to explain the table of value. So we have L/cm, and this is your composite parameters in the composite table, and your I in amps, and your L inverse/cm inverse. Good. And then the last one, I deliberately put I inverse/cm A inverse. I inverse slash A inverse. The reason why I did is that when you are preparing for any exams, you have to prepare in both ways, so that no matter what the examiners do, you stand your ground. So we are going to run the experiment 5 times. So write 1, 2, 3, 4, and 5, and then we'll draw a straight line here. Your table of values carries the highest mark in your physics experiments, so you better do it well or you score very low in your experiment. And I keep telling you that if you get 50 over 50 of physics experiments, making A1 with your prayers becomes inevitable. So write 20.00, write 35.00, write 50.00, write 65.00, write 80.00. That is that for that. So the next thing we are going to do is to connect the circuit diagram. This is the standard resistor that we're using. In this question, the resistance is 5 ohm, but I'm going to do it twice. We're going to do the one for this and this. So this is a resistor of 5 ohm. This is your ammeter. I have told you how to read your ammeter in the other video series. For the sake of emphasis, I repeat again. For this particular one, you see this is 0 to 1 up calibration, 0 to 3 down calibration. But we are connecting from 0 to 3, so I'm using the down calibration, which is 0.6 divided by 10. We give you 0.006. That is the value for each small line. So we have the ammeter, we have the key, we have the jockey, we have 2 cells. This is a battery. We have the battery or the cell rackets. Then we have the potentiometer. So we also have connecting wires here. Lovely. So it is time for us to connect the circuit diagram. This is PQ. So if you see, I draw something here. PQ. So I'm going to place PQ. PQ simply means our potentiometer. So this is our potentiometer. I'm going to place it here. That's our PQ. This way. Good. So that my reading is from 0 to 100. I'll read from left to right. So the next thing I'm going to put there is your R. Your R is 5 ohm. So for the sake of emphasis, let me quickly just tag this guy as my R. Good. So this is my R. And my R in this case is 5 ohm. So I'm going to place, this is my R, so I'll place my R here. This is my battery rackets. Battery means 2 cells. This is it here, so I'll place it here. Yes, the plus side is facing this side, so I'll place it here. The next thing is my ammeter. My ammeter is here. I'll place my ammeter here. The next thing is the key. The key is here, the other side, so I'll place my key here. The next thing is to start the connection. We'll start with the wire that runs from the potentiometer. So this is the wire that runs from the potentiometer. Yes, from the potentiometer, from here to here. From the potentiometer to the resistor. That is the wire. The next connection is a connection from the resistor to the battery. So the examiners will ask you to list precautions you took to get accurate reading. So one of them is that I ensured tight connection. So this is from the resistor to the battery. The next thing is from the battery to the ammeter. From the battery to the ammeter. So this is the battery, from the battery to the ammeter, to one leg of the ammeter. That is it. And one thing that makes you to know that your circuit diagram is correct is when you are done connecting and it reads anti-clockwise. The next thing is from the ammeter to the key. So from the ammeter to the key, that is, we are connecting 0 to 3. From the ammeter to the key, this side. So we place it here. The next thing is connection from the key to the resistor. From the key to the resistor. From the key to the resistor. Yes. From the key to the resistor. That's the next connection. Another connection is now from the what? The jockey we move from the resistor to the potentiometer wire. So we just click it here quickly. This is the jockey. So one precaution in this experiment is that I ensure tight connection. If your connection is not tight, you are not going to get accurate reading. So you're going to avoid error due to parallax by reading down straight, not like this, but you read down straight. So how do you state it? I avoided error due to parallax when taking reading on the potentiometer and the ammeter. Don't watch this way or this way. Look at it straight. So the next connection is from the resistor to that. So this is the connection. So we are going to put to test if this is correct. So this is the plus side, you face this side. So this is the connection. This is the connection. Wow, lovely. You can see that it is reading it's reading clockwise. You can see that it is reading. It is reading. It means that the connection is correct. Watch. It is correct. Good. So the next thing they ask us is to find the value of the current when the jockey was not in contact. This is the jockey wire. We are going to vary the jockey across this length of the wire. Mind you, a potentiometer is simply a variable resistor whose resistance is varied by tapping the jockey gently across the wire. So we are going to connect the circuit and find our peak I. Quickly. We have 1, 2, 3, 4, 5, 6. 6.5. 6.5 means we are using the down calibration as I showed you before. So the down calibration is 0.05 times 6.5. That will give us 0.39. So the peak current in the circuit when the potentiometer was not in contact with the circuit is simply 0.39. We are going to record this on top of the table of values here. On top here. So write that our I naught is what? Is 0.39 amps. You record that value on top of the table of values. You record it this way. Good. The next thing we are going to do right now is to quickly run the experiment proper. I'm not going to waste time. Now, When the length was 20, what was the reading? We now plug in the key and then gently tap this at 20. So let's do it. So this is 10, 1, 10, 11, 12, 13, 14, 15, 16. 16. So it means that 16 times 0.06, that will give me 0.96. So I write 0.96 here. 0.96. The next one is 35. Always remove the key to avoid battery drainage. The next one is 35. I plug my key again. I will tap this on 35. This is 30, 35. At 35 I have, this is 10, 11, 12, 13, 14, 14.5. 14.5. I will break the circuit to avoid battery drainage. So 14.5 times 14.5 times 0.06. If I do that, I have 0.87. So I'll have 0.87. The next one quickly is 50. When the length of the wire was 50, what do we have? Quickly, I will tap this at 50. So this is 50 middle of this. So let's count. This is 10, 11, 12, 13, 14. 14 on the dots. So I'll write that 14. 14 times 0.06. That will give me 0.84. Alright, 0.84. That is it. The next one quickly is when the length of the wire was 65. I'll close my key again and take a potentiometer wire and place it at 65. Where's 65? This is 60 and this is 65. Down here. So what do I have? This is 10, 11, 12, 13. I have 13 on the ammeter. But then I'll convert it by saying 13 times 0.06. That will give me 0.78. So write 0.78. The last one is when the length was 80. I will close my key and place this guy at 80. This is where my 80 is. And then read. This is 10, 11, 12, 12.5. I have 12.5. So I'll say that 12.5 times 0.06. I got 0.75. So I'll write 0.75. If you have this year's exam with you, I use 5 ohm here. Exactly what is in 2009. You observe that my table of value with them, my table of values and that of theirs in this textbook, there's no big difference. So let's quickly finish off the order. So we're done with the experiments. We are done with the main experiment. The next thing is to complete the table of values. So we have L inverse. L inverse simply means 1 divided by 20, you put the answer. 1 divided by 35, you put the answer. Then I inverse means 1 divided by this, 1 divided by this. So let's do it quickly. So we have 1 divided by 20. We have, you're going to record this column to 3 decimal places. L inverse and I inverse must be recorded to 3 decimal places. Remember in the other videos I told you that you have the roots, square roots, cube roots, logarithm, log A, log I, whatever. You have to record those stuff to 3 decimal places. While the other ones you have to record to 2 decimal places. So write that this is 1 over 20 will have 0.050. So we have 1 divided by 35, we have 0.029. Do the same thing for this. We have 1 divided by 0.96, you have 1.042. Then you have 1 divided by 0.87. 1 divided by 0.87. If you do that, what you have? You have 1.149. You have 1 divided by 50. You have 0.020. You have 1 divided by 65. You have 0.015. You have 1 divided by 80. You have 0.013. So you have 1 divided by 0.84. You have 1.190. You have 1 divided by 0.78. You have 1.282. You have 1 divided by 0.75. You have 1.333. So we are done with the table of values. Now let me predict something quickly. You see, there are 4 possible graphs that we are going to plot here. The graph of L against I. That is, you see, we're having an increase-decrease trend. As the value of L is increasing down, the value of I is decreasing down. 0.96 is greater than 0.75. So the graph of L against this, increase, decrease. This is increase, decrease, or decrease, increase. The graph of this against this, or this against this, will look like this. Now, we have another graph. The graph of L against, the graph of what? L inverse against I. The graph of L inverse against I. What you have here? You have decrease. You have increase. 0.05. This is decrease. This is decrease. You have decrease, decrease, down. Increase, increase, up. So any of this graph of I against L inverse or L inverse against I, will give you a graph that looks like this. We give you a graph that looks like this. This graph or this graph or this graph. This graph or this graph or this graph. Take notes. Now, I am taking time to explain this. Now, I said the graph of this against this or this against this. Lovely. Now, we may have a graph of L against I inverse. If you watch, this is increase. This is increase. From 1.042 down to 1.333. 1.333 is greater than 1.042. So a graph of increase against increase or decrease against decrease, decrease against decrease, we also give you a straight line graph passing through the origin, or having an intercept on the y-axis, or having intercept both on the x-axis and on the y-axis. Do you understand? So to this, we have come to the end of this particular video. In the next video series, I am going to plot all of this graph, and then we'll be done for the potentiometer experiment. Don't forget to subscribe and share these videos and all these videos to those that need it. Stay safe. God bless you. Bye bye.